welcome PreGraders to today's session. So today we're going to be looking at differential calculus. So as usual, we're going to start going through the basics just so that we can remind ourselves what differential calculus is, and then after that we're going to jump into the questions. Alright, so given any function, given a function f of x, that could be f of x is the same as is equals to 5, could be a parabola, could be a trigonometric function, could be a log function, could be any kind of function, okay, any kind of function. So given that function, if you are interested in finding the rate of change of that function at a certain point, so that's your function, I don't know, it's a function. If you were interested in finding the rate of change at a given point, so basically if we want to find the gradient at any given point, because we can see this is not a straight line, the gradient is not constant everywhere, so it changes all the time. If you want to find the rate of change like that, we have to derive the function, okay? So there are two ways of deriving, there are a lot of ways of deriving the functions, but there are two ways that we consider in grade 12. So there's from the first principle. So this uses the definition of the derivative from first principle. So this is quickly done by taking 2 points that can name that point x, that point x plus h, such that we have a gap here of h. Okay, so this is gonna give you, if this function is f, it's gonna give you f of x, the value, and then this value is gonna give you f of x plus h. Okay, so what we do here, we are taking the average gradient, so f of x plus h, that's that minus f of x, that's the same as y2 minus y1, then your x2, that's x plus h minus x, so the x and x cancels, we only left with h here. Okay, so we notice that when we take our h, when we make h as small as possible, we're getting closer to the true gradient, so that's why we're limiting our h approaches 0. So here you'll be given a function. Any function could be given x squared plus 3, and then you'll be told find the derivative that can be denoted as f prime of x dy dx, or dx of f of x, or dx of y, and then you'll be told to find that from first principles. So by doing that, that comes from the first principle, meaning the basics, like how we derive this function. So what you do here is apply this formula. So that's the same thing as taking your average gradient. The formula is there in your formula sheet. So you take your f of x plus h, you have to find your f of x plus h. So if your function is sine of x, just for an example, f of x plus h would be sine of x plus h. So you're gonna substitute x as x plus h, and then minus f of x, that's what you're given, all over 8. So all over h. So I'm gonna show you an example in our next example, and then I'm gonna show you how to do that. I want to show you how to do that. Okay, so the other way is when you're given this only works for polynomial functions. When given any, could be fraction, could be a function in a square root or anything, if we can express that function as a polynomial such that it's in this form. Remember, this can be any constant, this can be any constant as well, positive, negative, it doesn't matter. If we have it like that, so you can derive that function by finding the derivative as follows. So you take your exponent, you first have to write it in that form first. You take your exponent, multiply by the coefficient, and then you subtract 1 from that exponent. Okay, so same way here, that would be your m multiplied by b, so that's bm, then the y is this y, and then your m minus 1. And then the derivative of a constant is always 0. This comes from the fact that this is x to the 0, and then when you take the 0 and multiply by c, that's 0, and then it's 0x to the minus 1. So but this is just 0. Okay, so the derivative of a constant is always 0. We can use differentiation to find the gradients of functions at any given point, to find the turning points, okay, and to find the maximum and minimum points. All right, so I'm going to show some of this in our next examples, and then we're gonna have a good idea of what differential calculus is, and then how to tackle problems that involve differential calculus. All right, without any waste of time, let's just jump into our next questions. Okay, so the first question is as follows. Given f of x is equivalent to 2 over 3x, determine the derivative of f from the first principle. Okay, so we can see here they are being specific in how should we find the derivative. This is from the first principle. Okay, as I've indicated in the basics, this is the formula for finding the derivative from the first principle. Okay, where we're using the average gradient by limiting the distance between the 2 points, which is h to 0. Okay, so this formula is given in your formula sheet. So the first thing to do, we're noting, because this is just given, our f of x is 2 over 3x, and then our f of x plus h, which is that term, would be 2 into 3x plus h, all in brackets, and that is 2 into 3x plus 3h. Okay, so substituting into the formula, the derivative of x would be limit as h tends to 0, and then we have, and then we're gonna have, that's 2 over 3x plus 3h minus 2 over 3x all over h. Okay, so I'm gonna rewrite this as limit h goes to 0, and then it's actually like this. So it's actually just gonna be 2 over 3x plus 3h minus 2 over 3x multiplied by 1 over h. So this is just the same as dividing by h, but I prefer writing it this way because it looks a bit better. I can easily manipulate this without worrying over the fact that I have a fraction of a fraction. But if that doesn't bother you, you can still continue this way. So continuing, I'll limit as h approaches 0. I can see here that I'm subtracting 2 fractions. Okay, so I need to find the lowest common denominator, lowest common multiple, which would easily be this multiplied by that. So that's 3x plus 3h multiplied by 3x. Okay, so still have them 1 over h. And then, so how do we proceed? We're gonna say for this term, how many times does this go into this common denominator? And then it goes 3x, because it's the same thing as how many is dividing this thing by that. So that and that are gonna cancel out, and then we're left with 3x, which we multiply by this numerator here. So we have 6x, and then doing the same thing, we're gonna get minus 6x, because we're saying how many times does this go in here? It goes 3x plus 3h. So that multiplied by 2 is 6x plus 6h. Okay, so we can see that 6x is gonna cancel 6x. So at the top, we're gonna be left with 6 minus 6h over 3x plus 3h multiplied by 3x, and then that's multiplied by 1 over h. Okay, so we can see that h and h are gonna cancel out. So after h, the 2h are being cancelled out, we left with still have limit h approaches 0. So limit h approaches 0. So we left with minus 6 over, we have 3x plus 3h, and then this is multiplied by 3x. Okay, this is still a derivative. And then, so we can see at this point we've reached a point where we can actually say, because remember this whole limit h approaches 0, we want to make h as small as possible. So at this point we can say, but we can substitute our h as 0 such that h is very, very small, and it's so close to 0 that we can just say it is 0. By doing that, we can see we're not making the function to be undefined. Unlike at this stage, if you were to put 0 here, the whole thing would be undefined because we're dividing by 0. So but now we can see that the equation is actually minus 6 over 3x plus 3 into 0, that's h into 3x. Okay, so that works out to be minus 6. So after substituting, you don't have to write limit as h approaches 0 because we have already made our h to be 0. So that works out to be over 9x squared because this term is 0, and this is the same as minus 2 over 3x squared. So that's the final answer. Okay, so a quick way of confirming this, we're given let me just use a different, so we're given f is 2 over 3x, and then we can write this as it's the same as 2 over 3x to the minus 1. So taking the derivative of that would be minus 1 times that's minus 2 over 3x to the minus 2, which is the same thing as that. Okay, so that's what you should do in an exam room. After doing it from first principle, on the side just do it, just confirm it, and then so that you know you've secured all the marks. Okay, so our next question, they're saying determine f prime of x, that's the derivative of f, if f of x is equivalent to 3 into x squared minus 5 all squared. Okay, so here they're not saying we should use first principle, so we're gonna use the easiest way, which is expressing this in a form of polynomial. Remember we spoke about y being ax to the n, so you want to express everything in that form, and then we'll take it from there. Okay, so we'll start here. So that's our f of x is the same as 3x squared minus 5 all squared. So we can start by simplifying that as 3x squared minus 5 into x squared minus 5. So this becomes 3, then this by that, that's x squared, this by that, that's minus 5x, this by that, okay, that's squared, this by that, minus 5x squared, and then minus 5 by minus 5, that's positive 25. Okay, so we have 3, and then we're gonna have so this was x to the 4, so because it's x squared by x squared, so we're gonna have x to the 4 and then minus 10x squared plus 25. We still have the 3 that we need to multiply throughout this whole bracket, so we have 3x to the 4 minus 30x squared, and then plus 75. Okay, so now we have expressed every single thing in this equation, in this f of x, in the form of, let me write it in a form of y is equivalent to ax to the n, and we know the derivative of that, which is just y prime, is an x n minus 1. Okay, so then we can apply that throughout everything here. Then we'll see that derivative of x here will be the same as 4 by 3, that's 12, x 4 minus 1, that's 3, minus, so that's 2 by 30, that's 60, x, and then 2 minus 1, that's 1. So 75 can be thought of as 75 x to the 0. Okay, so such that we know the derivative of a constant is 0, but I just want to show why is it 0. So such that when you derive this, it's going to be 0 by 75, so that's plus 0, and then all into x, 0 minus 1, that's minus 1. So this whole thing is 0, you see. So that's why we're saying derivative of any constant is 0. Okay, so now our final answer would just be 12x cubed minus 60x. That would be the derivative of that function. Our next question is determine dy dx. That's still the derivative as I've explained. If x squared minus 3 is the same as the cube root of y. Okay, it looks a bit tricky, but it's actually not. Let's just see. So we have x squared minus 3 is equivalent to the cube root of y. Okay, so remember now this is the same as, okay, first of all, we need to put this in a form of y is equivalent to some polynomials, ax and plus bx, something like that. Okay, so we need to put our y as the subject of the formula here before anything else. So we can see, we know that x squared minus 3 is basically the same as y to the 1 of 3 to a third, y raised to a third. Okay, so we can cube all the sides here. We can raise everything to the power of 3 such that we have x squared minus 3 to the 3, and then we have y to the 1 over 3 all to the 3. So now we're gonna have x squared minus 3 into x squared minus 3 into x squared minus 3, and then that's gonna be equivalent to just y. Okay, so I'll rewrite it. So that's gonna be y the same as, we can start multiplying the first two brackets. So that's going to be x by x, that's x to the 4, and then that's minus, okay, so that's going to be minus 6x. Okay, so the minus 6x comes from minus 6x squared, so that's going to be minus 3 by x squared, and then this minus 3 by x squared. Okay, so, and then plus 9, that comes from minus 3 by minus 3, so that still has to be multiplied by x squared minus 3. Okay, so continuing, we're going to start with this one. So x squared by x squared, that's x to the 4. Okay, so this is x to the 4. So this is x to the 4, it comes from x squared by x squared. Okay, so now when you multiply this, it becomes x to the 6. Remember, we're adding exponents when we have the same base. So this is x to the 6. And then x squared by minus 6x squared, we get minus 6x to the 4. And then x squared by 9, that's plus 9x squared. And then we multiply the 3 now. So 3 into x to the 4, that becomes minus 3x to the 4. And then 3 multiplied by there, that becomes minus, since it was minus, it's going to be positive 18x squared. And then 3 by 9, that becomes minus 27. So we can add our like terms. We're still going to have x to the 6. And then anything with x to the 4, that's minus 6. And minus 3. So it becomes minus 9x to the 4. Okay, and then we're adding the like terms again for x squared. So that's going to be 9 plus 18, so that is going to be plus 27x squared, and then the remaining term, if I'm not mistaken, is going to be minus 27. Okay, so that's simplifying this whole thing by adding the like terms. Okay, so after this simplification, we can go ahead and find dy dx. So that's going to be 6 multiplied by 1, so that's 6x to the 6 minus 1, that's 5, minus 4 multiplied by 9, that's going to be minus 36x, and then 4 minus 1, that's 3, and then plus 27 by 2, that's 54, just x because it's 2 minus 1, and then this is the derivative of a constant is 0, that's going to be minus 0. So that is the final answer. Alright, so after going through the statement, we are told that, or we are asked that after going through our problem statement, the first question we are asked to express y in terms of x. Okay, I've quickly redrawn the whole figure here. So this is the rectangle, and then that's a triangle. So we are asked to express y in terms of x. Okay, and then we are given a hint that triangle ABC is similar to triangle APQ. Okay, so that's our hint. Okay, so now what does the similarity mean? It means that everything is in proportion when comparing this triangle. So this side is in proportion with this side, just as this side is in proportion with this side, just as this side is in proportion with this side. Okay, so what does that mean? Okay, so it means if we were to take ratios of each side, they're going to be the same. So meaning, if I can say x over 10, what does this mean? I took the base of the small triangle divided by the base of the bigger triangle. That would be the same as taking maybe this side of a smaller triangle over the overall side of the bigger triangle, or this side AP of the smaller triangle over AB. Okay, so but we see our y is a perpendicular distance. Okay, so our y is a perpendicular distance again, but we've been given the perpendicular height of the bigger triangle as 8. Okay, so we just need to find the perpendicular height for a smaller triangle. We can see if the whole thing is 8 and this is given as y, so this one has to be 8 minus y. Okay, and then from there we can simply solve for y, and then we would have expressed y in terms of x. So I'm going to start by cross multiplying here. So this by that, I'm going to get 80 minus 10y. That's the same as 8x. Okay, so taking my 80 to the other side, I have minus 10y, the same as 8x minus 80. Alright, and then I can divide by 10. I get my y to be minus 8 over 10x minus 8. Okay, that's going to be plus because minus divided by minus. So that's my expression of y in terms of x. Okay, our next question says, hence show that the area of the rectangle can be expressed as a, which is equivalent to 8x minus 8x squared all over 10. Okay, so keeping in mind, we have found that y is the same as minus 8 over 10x plus 8, right? I know we wrote it as minus 4 over 5. It's exactly the same thing. Okay, so now we need to show that the area of this rectangle can be expressed as what they show us here. But we know area for any rectangular figure is the breadth times height of that rectangle. So in this case, we can take our breadth to be x, which is that, and then multiply by our height, which we found to be minus 8 over 10x plus 8. Okay, so when you have that, now you can further simplify this. So you're getting you can multiply throughout, you're getting minus 8 over 10x squared plus 8x. So that's what you had to do for this question. Okay, so our next question, we have been asked to determine the dimensions in terms of length and width of the rectangle for it to be maximum. Okay, so this is the rectangle, so we want the dimensions, the values of x and y for this rectangle to be maximum inside this triangle. Okay, so what determines if a triangle is big or small, maximum or minimum? That would be the area of that triangle, of that rectangle. And we have already found the area from the previous question, that the area function is 8x minus 8 over 10x squared. Okay, so we want the maximum value of this function. Okay, so we can see that this function looks like, first of all, there are two things we can observe from this. The first one, this is a parabola. Okay, this is a parabola. And then the second one, it's a parabola facing down. Why am I saying that? It's a parabola because the maximum number that x is raised to is 2, which means this is a quadratic. And then we can also see that the coefficient of x squared is negative, so your graph would be facing down. So we can see it does indeed have a maximum at that point. So we need to find the x value here, which makes this function to be maximum. But how can we do that? We can do that by applying the differentiation. Why? Because when you derive a function, you're getting a gradient function of it. So we can see here that the gradient is positive because this function is increasing, and then it gets to a point where the gradient is 0. That point is the maximum, where the gradient is 0, and then it starts decreasing. Then the gradient starts being negative. Can you see it? So we're looking for an x value where the gradient is 0. But first of all, we need to find the gradient first. Okay, so the gradient function can be found by deriving this area function. So we can say dA dx would be, okay, so this is 1 multiplied by 8, and then x to the 1 minus 1, which is 0. Okay, so x to the 0 is just 1. I'm just gonna leave it like this, and then this becomes 2 multiplied by that. That's 16 over 10. X to the 2 minus 1 is 1, so x to the 1. So that's our gradient function. So we're looking for a point where the gradient is 0, which we have seen on that drawing that is going to be a point where the function is at its maximum point. So now we can equate that to 0. We can say dA dx is equals to 0 at maximum point. Okay, that's what I've shown. So we can equate this to 0 and solve for x. So by doing that, so we're saying 8 minus 16 over 10x is equals to 0. We can take this to the other side, so we have 8 is equivalent to 16 over 10x. Okay, so you can divide by 16 over 10. You can see that your x would be 5. What units were we using? That would be 5 centimeters. So that's the length of this x for it to be maximum. But now we still need to find the y. Okay, so your y would be, we have found that your y is the same as 8 minus 8 over 10x, which means your y is 8 minus 8 over 10 into 5, and then this works out to be 4 centimeters. So that's how you find the maximum dimension, the dimension that will make this rectangle to be maximum inside the triangle. So the maximum corresponded to the turning point, or the maximum point of this function, and then to find that, we know at the maximum point or the turning point the gradient is 0. We solve for x. After solving for x, and then we know the x value, then we can find the dimensions. Okay, if we were asked to also find that maximum area, we would simply just take x and then put it in here, and then we're going to find the area. Alright, so our last question is as follows. We are told a car has 4 liters of petrol in a tank. After driving 80 kilometers, the car has 2 liters of petrol left. So the graph below shows the car's petrol consumption and the distance traveled. So we can see we're given a graph, and then this is the distance. I think this is in kilometers. That's the distance traveled in kilometers, and then this is the petrol left in the tank in liters. Okay, so we're told that this graph is L, and then the first question they're saying to us, determine the gradient of the line L. Okay, so we need to determine the gradient of the line L. We can see that the line L is a straight line. Okay, so the gradient, which is M, is going to be changing, you can say changing y over changing x as we know it, which is equivalent to be changing a y variable, which is going to be petrol, over changing distance, which is your x variable. So this is going to be, you can take any point. I'm going to take this point as my first coordinate, which is 0 and 4, because we're told initially when 0 distance is traveled, the car had 4 liters, and then I'm going to choose this other point, which we also told it's 80. It is 80 and 2. This point, both these points are given, so you can find the gradient now. So you can take y2 minus y1 over x2 minus x1. So I can start with this, gonna be 4 minus 2. That's 4. That is so that is 4 minus 2. The y values all over 0 minus 80. So that's y2 minus y1, x2 minus x1. So now this becomes minus 1 over 40. Okay, but what are the units? The units would be liters per kilometer. Okay, liters per kilometer. All right, so that's the first question. So our very last question is as follows. We are asked to explain the significance of the value of the gradient obtained. So we calculated the gradient, and then we have seen that our gradient is equals to minus 0.025 liters per kilometer. Okay, so now basically they want us to explain what does this mean. Okay, so looking at the gradient, there are two things that we can get out of this. First of all, we're gonna get information from the magnitude of the gradient and then the sign of the gradient. The magnitude tells us that the car, it tells us that the car consumes 0.025 liters for every kilometer traveled. I'll just say every kilo traveled. Okay, that's what we're getting from this. Obviously the gradient says that we have 0.025 liters per kilometer. That's what it means. And then the second part, the negative. Remember, our dependent variable here is the petrol inside the tank. So the second part tells us that the petrol is actually decreasing, or the function is decreasing. But what is the function in this case? The function is petrol in liters. So the petrol in the tank decreases as the car travels. Okay, so that's what they wanted us to explain. Basically, we're looking at the magnitude and both the sign of the gradient. Okay, so this sums up all the work that we wanted to do for as far as differential calculus is involved. So the only left part is where we have to apply differential calculus to functions so that we can find turning points and tangents. So we're gonna do that in our next video. Stay tuned, and then don't forget to like and subscribe our videos.